My name is S. Karunya Sai, and my topic in signals and systems stochastic process is uh, power spectrum density definition and interpretation. Power spectrum density (PSD) quantifies the power of a signal as a function of frequency. It indicates how power is distributed across the frequency in a signal. It is the definition of the power spectrum density. Signal analysis power spectrum density helps in identifying dominant frequencies and signal behavior over time. Noise identification distinguishes between noise and actual signal, aiding in filtering and signal processing. Applications of usage uh, power spectrum density across various fields: telecommunication, audio processing, seismology. In telecommunication, optimizing bandwidth and signal integrity. In audio processing, enhancing sound quality and identifying audio features. And seismology, analyzing earthquake data or frequency content. The units of this power spectrum density is watts per H. Fourier transform converts time domain signal into frequency domain. Autocorrelation function power spectrum density the Fourier transform of the autocorrelation of the signal. Power per unit frequency. Power spectrum density represents power of a as a function of frequency. Typically is in units like watts per H. For continuous signal, where is the Fourier transform of the signal? For discrete signal, power spectrum density is typically estimated using periodograms or methods like Elchek's method. Power spectrum density interpretation. High power spectrum density at frequency indicates more power at the frequency. Low power spectrum density at a frequency indicates less power at a frequency. Continuous versus discrete signals. Continuous signal. Continuous power spectrum density function. Discrete signals. Power spectrum density is represented as a discrete points. It is a graph represented power spectrum density. In this graph, uh, the experiment is doing in three times. The red color of the signal is the power of the signal. The y-axis is amplitude and x-axis is edges. These are the examples of power spectrum density. You can find out the power of a signal using this PSD. In this interpretation, high power spectrum density at frequency indicates more power at the frequency. Low power spectrum density at frequency indicates the less power at the frequency. Continuous versus discrete signal. In continuous signal, the power spectrum density functions is continuous function. In discrete signals, the power spectrum density represented as discrete points. As we learn in continuous versus discrete, continuous, the time period occurs at all time of the intervals, but discrete is specific sum of intervals. These are the two. This is another example of power spectrum density. It is the by using PSD we can find out the power of a signal. Uh, in y-axis amplitude and x-axis is hertz. In y-axis amplitude, the units are g square by hs. The red line PSD data indicates 1 Hz and green line PSD data 1 indicates 4 Hz frequency, and PSD blue line indicates 8 Hz. The graph is plotted between 0 to 6000 Hz and amplitude 0 to 0.1217 into e to the power of minus 3. You can find out any signals, discrete signal or continuous signal. For discrete signal, uh, the continuous power spectrum density function for discrete represented the discrete points. Thank you.